Bay of Biscay, March 27, 1944, 0600 hours, and Kapitänleutnant Wilhelm Steinberg stood on the bridge of U-960 as his Type VIIC submarine moved through the pre-dawn darkness toward La Pallice. The concrete reinforced hulls of two Sperrbrecher vessels flanking his boat while 4M-class minesweepers formed a protective screen, their multiple 20mm and 37mm flak guns bristling in the morning twilight, ready to unleash a wall of steel against any Allied aircraft foolish enough to attack. Completely unaware that 6 British Mosquitos and 2 specially modified Tsetse variants were already approaching from an altitude of 5,000 feet, their 57mm Molins guns loaded with armor-piercing shells designed to strike from beyond the effective range of German anti-aircraft defenses. The convoy had been sailing through the night with the confidence that came from Admiral Karl Donitz's new defensive doctrine, which grouped submarines with heavily armed escort vessels to create overlapping fields of anti-aircraft fire, a strategy born from the devastating losses of 1943 when lone U-boats had been caught on the surface by Allied aircraft. But what Steinberg and his fellow commanders didn't know was that the British had developed a weapon specifically designed to defeat this tactic, mounting a modified 57mm anti-tank gun in the nose of their fastest twin-engine fighter bomber, creating a flying artillery piece that could engage targets at 1,800 yards, well beyond the accurate range of German 20mm flak, which became ineffective past 2,000 meters, and significantly outside the envelope where 37mm guns could track and engage fast-moving aircraft effectively. The development of this weapon had begun in 1943 when the British Air Ministry recognized that German U-boats had started fighting back against attacking aircraft rather than diving, with boats like U-441, converted into the heavily armed U-Flak-1 with 2 quadruple 20mm flak-virling cannons and a 37mm gun, creating floating anti-aircraft platforms that could put up a devastating barrage against conventional attack aircraft, forcing them to approach within 500 meters to drop depth. Charges or fire rockets, a range where even the most heavily armored Coastal Command aircraft became vulnerable to the concentrated fire of multiple automatic weapons. The solution came from an unlikely source, the Molins Company of Peterborough, a firm that had spent decades manufacturing cigarette-making machinery and had developed sophisticated automatic feeding mechanisms for their production lines, technology that Desmond Molins and his engineers realized could be adapted to create an auto-loading system for the British Army's QF 6-pounder anti-tank gun, transforming a manually loaded weapon into a semi-automatic cannon capable of firing 55 rounds per minute, though the aircraft installation would carry only 25 rounds due to weight restrictions. When de Havilland engineers at Hatfield first examined the possibility of mounting this weapon in a Mosquito, they faced the challenge of installing a gun that weighed 1,580 pounds fully loaded, with a barrel that projected forward of the aircraft's nose, requiring the complete removal of the 4 20mm Hispano cannons that normally equipped the fighter-bomber variant, leaving only 2 303 Browning machine guns for aiming purposes, but the trade-off seemed worthwhile when tests showed the 57mm shell could penetrate a submarine's pressure hull through 2 feet of water at a range of 1,400 meters, far beyond the distance where German gunners could effectively engage a fast-moving aircraft. The first prototype, converted from Mosquito FB Mark VI HJ732, underwent firing trials in June 1943 at the de Havilland Works, with test pilot Pat Fillingham reporting that the aircraft bucked violently when the gun fired, the recoil causing rivets to shear in the forward fuselage until reinforcing struts were added along with a massive hydraulic buffer beneath the gun that created a distinctive bulge on the aircraft's belly, modifications that added 900 pounds of armor plating around the engines and cockpit floor to protect against return fire from the heavily armed submarines that had become the primary target. Squadron leader Tony Phillips of 248 Squadron had been flying Mosquitoes over the Bay of Biscay since December 1943, transitioning from Beaufighters just as the German U-boats had started sailing in convoy formation with surface escorts, a tactical change that made traditional low-level attacks with depth charges nearly suicidal. But the arrival of the first Tsetse variants in March 1944 offered a new approach, allowing his squadron to engage from distances where German flak gunners struggled to track the fast-moving aircraft, their 20mm shells falling short or wide as the Mosquitoes maintained their distance. The German perspective on anti-aircraft defense had been shaped by their experience in the Mediterranean, where Hauptmann Friedrich Christiansen, commanding a flak battery in occupied France, had trained his gunners to engage low-flying aircraft at ranges under 1,000 meters, the sweet spot where the 20mm Flak 38 could reliably hit a target moving at 300 miles per hour, But the mathematics changed dramatically when the target remained at 1,500 meters or more, forcing gunners to lead their targets by such extreme angles that even minor errors in estimation resulted in complete misses. The Italian Regia Marina had learned similar lessons during their convoy battles off Sicily, where Capitano di Corvetta Giuseppe Fontana, commanding the escort vessel Orsa, discovered that his ship's battery of Breda 20mm guns could create an impressive curtain of fire but rarely scored hits on British Beaufort torpedo bombers that released their weapons from beyond 1,000 meters, prompting Italian naval commanders to request German 37mm guns that could reach out to 4,800 meters, though even these weapons struggled with the deflection shooting required against aircraft approaching at oblique angles. In the submarine pens at Lorient, Korvettenkapitän Hans Rudolf Rosing, commanding the 2nd U-boat flotilla, had watched the evolution of Allied anti-submarine tactics with growing concern, noting in his war diary that British aircraft seemed to possess an uncanny ability to locate U-boats even when they were traveling with heavy escort, unaware that ultra-intercepts were providing coastal command with precise routing information. But even more troubling was the report from U-960's previous patrol where Oberleutnant zur See Gunther Heinrich had observed British aircraft maintaining their distance from the defensive convoy, apparently conducting reconnaissance but never closing to attack range. The Japanese had their own encounter with this new threat scheduled for May 10, 1944, when submarine I-29, carrying vital technical information from Germany including Walter rocket engines and Enigma machines, would be protected by German destroyers Z-23 and ZH-1 Junkers Ju-88 fighters. But Commander Takakazu Kanashi had no knowledge of the weapon that would engage his escorts, watching through his periscope as British Mosquitos approached, then inexplicably opened fire from what seemed an impossible distance, the explosions of 57mm shells against the destroyer's hull sending splinters across the water as one of the Ju-88s suddenly shed its port engine, torn completely away by a single shell from squadron leader Philipps's Tsetse. Back on U-960's bridge that March morning, Steinberg ordered his lookouts to maintain vigilance as the convoy approached the swept channel into La Pallice, the 4M-class minesweepers maintaining station at 500 meters while the 2 Sperrbrecher vessels, their hulls reinforced with concrete to absorb mine blasts, led the formation through waters that British aircraft had been mining for months, their 20mm and 37mm guns manned and ready, ammunition belts loaded with a mixture of high explosive and armor-piercing rounds that could theoretically engage aircraft at ranges up to 4,000 meters, though everyone knew that practical accuracy dropped off dramatically beyond 2,000. The evolution of German naval anti-aircraft defenses had been reactive rather than proactive, with the Kriegsmarine initially believing that U-boats could avoid aircraft by diving quickly when spotted, a tactic that worked well in 1940 and 1941 when Coastal Command had limited numbers of aircraft and poor detection equipment. But the introduction of centimetric radar that German detection equipment couldn't sense, combined with Lee lights that illuminated submarines at night, had shifted the balance decisively in favor of the hunters, forcing submarines to remain on the surface and fight it out with attacking aircraft. The U-Flak experiment had been Admiral Donat's attempt to turn the tables, converting boats like U-441, U-256, U-621, and U-953 into floating anti-aircraft platforms with quadruple 20mm mounts and enhanced 37mm guns, their torpedo load reduced to just 5 to make room for additional gunners. But the results had been disappointing, with U-Flak boats claiming only 2 aircraft definitely destroyed while suffering heavy casualties when Allied aircraft adopted new tactics, circling at a distance, while calling in additional planes to launch coordinated attacks that overwhelmed the defensive fire. Lieutenant Wolfgang Müller, gunnery officer aboard U-256 during its conversion to U-Flak configuration, had written to his wife describing the impressive firepower of the quadruple 20mm mount, capable of firing 800 rounds per minute when all 4 barrels were engaged, creating a stream of tracers that looked like a solid rope of fire reaching toward attacking aircraft. But he also noted the limitation that magazines held only 20 rounds per gun, requiring frequent reloading that created dangerous gaps in the defensive barrage, windows of vulnerability that experienced Allied pilots learned to exploit. The British had been developing their response to the U-boat threat across multiple fronts, with scientists at the Telecommunications Research Establishment creating new radar systems that could detect periscopes at 5 miles, while weapons designers at the Royal Aircraft Establishment experimented with various anti-submarine weapons, including the highball-bouncing bomb and various guided weapons, but it was the straightforward approach of mounting a large-caliber gun that proved most practical, especially after the Molins company demonstrated their automatic loading mechanism could reliably feed the heavy 57mm shells without jamming. Wing Commander Peter Wycombe Barnes, serving as Deputy Director of Operational Requirements at the Air Ministry, had pushed for the Mosquito Tsetse project despite skepticism from officers who believed rockets provided adequate anti-shipping capability, arguing in a June 1943 memorandum that the 57mm gun offered superior accuracy at extended ranges, noting that trials had shown a 33% hit rate against tank-sized targets compared to just 5% for rocket projectiles, though he acknowledged that rockets were more versatile and could be fitted to any fighter-bomber without extensive modification. The manufacturing process at the Molins factory in Peterborough had required significant adaptation from their normal cigarette machinery production, with workers who had spent years creating precision mechanisms for handling tobacco and paper now crafting autoloaders that could reliably cycle 2-pound brass cartridges and 6-pound shells, the feeding mechanism using a 5-tray system similar to their cigarette packaging equipment but reinforced with heavy-gauge steel and powered by hydraulic rams that could overcome the G-forces experienced during violent combat maneuvers. German intelligence had received fragmentary reports about British experiments with heavy aircraft armament, with Abwehr agents in Portugal reporting rumors from British aircrew who had made emergency landings in neutral territory, describing a flying 6-pounder that could destroy submarines with single shots. But these reports were dismissed at Naval High Command as propaganda, with staff officers arguing that the recoil from such a weapon would tear any wooden aircraft apart, unaware that de Havilland engineers had solved the recoil problem with their hydraulic buffer system and structural reinforcements. The morning of March 27th brought perfect conditions for an anti-shipping strike, with cloud cover at 3,000 feet providing concealment for the approaching mosquitoes while gaps in the overcast allowed them to spot the German convoy from altitude. Squadron Leader Phillips leading the formation in Mosquito 18 NT-225, his navigator Flight Officer Thompson checking their position against the estimated track of U-960 provided by intelligence sources, though neither man knew that their target information came from ultra-intercepts that had decoded German naval signals describing the exact route and timing of the submarine's passage. In the operations room at 19 Group Headquarters in Plymouth, Air Vice Marshal Brian Baker monitored the progress of the strike force through position reports relayed by wireless, knowing that this mission would test whether the Tsetse concept could work against heavily defended convoys. The previous success against individual submarines providing insufficient data about how the weapon would perform when facing concentrated anti-aircraft fire from multiple vessels, especially the purpose-built Flak ships that German convoys had started including in their escorts. The Sperrbrecher vessels presented a particular challenge. These converted merchant ships carrying up to 8 20mm guns and 4 37mm weapons in addition to their concrete armor, commanded by experienced Kriegsmarine officers who had learned to coordinate their fire with other escorts to create interlocking fields of flak that could engage aircraft approaching from any direction, their crews trained to maintain steady fire even when under attack, unlike merchant sailors who might panic when faced with diving aircraft. Captain Zur See Robert Gysi, who had commanded Sperrbrecher vessels since 1942, had developed standard operating procedures that positioned his ships to provide maximum anti-aircraft coverage for submarine convoys, instructing his gunners to engage any aircraft that approached within 4,000 meters regardless of whether it showed hostile intent, arguing that in the Bay of Biscay any British aircraft should be considered a threat, though this aggressive stance had resulted in several incidents where German aircraft had been fired upon by their own forces. The mathematics of anti-aircraft gunnery were unforgiving, requiring gunners to calculate the speed and direction of their target, estimate the time of flight for their shells, and aim at where the aircraft would be rather than where it was, all while their own vessel pitched and rolled in the Atlantic swell, factors that became exponentially more difficult as range increased, with the probability of a hit dropping from perhaps 10% at 1,000 meters to less than 1% at 3,000 meters, even with the assistance of sophisticated ranging equipment. Italian naval gunner Sergeant Giovanni Martinelli, who had transferred to German service after Italy's surrender and now manned a 37mm gun on a Sperrbrecher vessel, later recalled the frustration of engaging British aircraft that seemed to hover just outside effective range, their crews apparently aware of the exact distance where flak became ineffective, leading to long exchanges of fire where thousands of rounds were expended without either side scoring hits, battles of attrition that drained ammunition supplies and exhausted gun crews without achieving decisive results. The Japanese naval attaché in Berlin, Rear Admiral Kojima Hideo, had observed German anti-aircraft training and noted in his reports to Tokyo that while the weapons themselves were excellent, particularly the 37mm Flak 36 with its high rate of fire and effective ceiling of 4,200 meters, the human element remained problematic, with gunners requiring months of training to develop the instinctive lead calculations needed for effective shooting, skills that were increasingly difficult to develop as experienced instructors were pulled into combat units to replace casualties. On U-960's bridge, Steinberg swept the horizon with his binoculars as the convoy entered the final approach to La Pallice, the familiar outline of the massive concrete U-boat pens visible in the distance, their roofs covered with anti-aircraft positions that could add their fire to any defensive action. But something made him uneasy, perhaps the reports from other boats about British aircraft behaving strangely, maintaining distance rather than pressing home attacks, as if they were waiting for something or testing new tactics that the Kriegsmarine had not yet encountered. The development of the Mosquito itself had been remarkable, conceived as an unarmed fast bomber that would rely on speed and altitude rather than defensive armament, built primarily of wood at a time when other nations were transitioning to all-metal construction. Yet this unconventional approach had produced one of the most versatile aircraft of the war, capable of operating as a fighter, bomber, reconnaissance platform, and now as a flying anti-tank gun, its Rolls-Royce Merlin engines giving it a top speed of over 400 miles per hour. Geoffrey de Havilland Jr., the company founder's son and chief test pilot, had been instrumental in proving the Mosquito's capabilities, demonstrating that the wooden construction actually provided certain advantages, including the ability to absorb battle damage that would cripple metal aircraft, while the smooth plywood skin created less drag than riveted aluminum, contributing to the aircraft's exceptional performance, though he could never have imagined that his father's design would eventually carry a weapon originally intended for destroying tanks. The morning sun had climbed higher, burning through gaps in the cloud cover to illuminate patches of ocean in brilliant silver, conditions that would normally favor the defenders by silhouetting attacking aircraft against the sky, making them easier targets for anti-aircraft gunners. But squadron leader Phillips had positioned his formation to attack from the east, keeping the sun behind them as they began their descent from 5,000 feet, throttling back to maintain a steady approach, speed that would give his navigator time to line up the gun sight on the leading Sperrbrecher. The German convoy's formation reflected lessons learned from 2 years of battles in the Bay of Biscay, with the minesweepers positioned to provide overlapping fields of fire while maintaining enough separation to avoid multiple vessels being damaged by a single bomb or torpedo, the Sperrbrecher vessels leading to absorb any mine detonations while their heavy armament could engage aircraft attempting frontal attacks, and U-960 tucked safely in the center where it could crash dive if the escort screen was penetrated, though Steinberg knew that diving in these shallow coastal waters was dangerous with British aircraft potentially marking his position for hunting destroyers. Flight Officer Turner, piloting the 2nd Tsetse Mosquito MM-425, watched Phillips's aircraft begin its attack run, noting the steady stream of tracers rising from the German convoy as every gun that could bear opened fire, the 20mm shells self-destructing at 2,000 meters in puffs of black smoke while the 37mm rounds continued past, their tracers burning out at 3,000 meters though the projectiles traveled much further, invisible but still potentially lethal to any aircraft unlucky enough to be hit by the ascending steel. The accuracy of the 57mm Molins gun had surprised everyone during trials, with test pilots discovering they could consistently hit a tank-sized target at 1,500 yards once they learned to compensate for the slight downward pitch caused by the gun's recoil, the heavy hydraulic buffer absorbing most of the weapon's kick but still producing enough force to affect the aircraft's trim, requiring pilots to maintain steady pressure on the control column during firing sequences to keep the sight picture stable. In Berlin, Gross Admiral Karl Donitz studied the latest loss reports from the Bay of Biscay, noting with concern that U-boat casualties had not decreased despite the implementation of convoy tactics and enhanced anti-aircraft armament, leading him to suspect that the British had developed new weapons or tactics that negated German defensive measures, though his staff assured him that the concentration of firepower from multiple vessels should make close-range attacks prohibitively costly for enemy aircraft. The Italian experience in the Mediterranean had shown similar patterns, with Ammiraglio Raffaele de Courten reporting to Supermarina that British aircraft seemed to possess an ability to damage vessels without closing to normal attack ranges, particularly during night operations when gun crews struggled to track fast-moving targets, though he attributed this to improved torpedo technology rather than considering the possibility of standoff gunnery, an oversight that would cost the Regia Marina several vessels in the final months before Italy's surrender. Japanese submarine doctrine had always emphasized avoiding surface engagements with aircraft, with boats like I-29 designed to crash dive in 30 seconds when threatened, but the long transit through the Bay of Biscay to reach German ports made this tactic impractical, forcing Japanese commanders to rely on German surface escorts whose effectiveness they privately questioned, especially after reports reached Tokyo of mounting losses despite increasingly heavy anti-aircraft armament on U-boats and their escorts. The first 57mm shell from Phillips's Tsetse struck the leading Sperrbrecher vessel just above the waterline, the armor-piercing projectile punching through the converted merchantman's hull plating before detonating inside an ammunition storage compartment, sending a column of smoke and flame through ventilation shafts as secondary explosions rippled through the ship's interior, the German gun crews maintaining their fire even as damage control parties rushed to contain the spreading fires. Their training overcoming the natural instinct to seek cover. Steinberg watched in disbelief as the British aircraft continued its attack run from beyond effective flak range, firing measured shots that struck with devastating accuracy, each impact marked by the distinctive crack of a heavy-caliber shell penetrating steel, a sound he had never heard during previous air attacks where bombs and depth charges provided the primary threat. This new weapon changing the entire dynamic of the engagement by allowing the attacker to remain outside the envelope, where German gunners had trained to engage. The mathematics were stark and unforgiving, with the 57mm Molins gun capable of accurate fire at 1,800 yards while German 20mm Flak became ineffective beyond 2,000 meters, creating a killing zone where the Mosquitoes could operate with relative impunity, their wooden construction making them difficult to track with optical rangefinders while their high-speed complicated deflection calculations, factors that combined to give them a decisive advantage over the convoy's defenders. Oberleutnant Friedrich Weber, commanding one of the M-class minesweepers, ordered his 37mm gun crew to engage the attacking aircraft despite the extreme range, hoping that the larger caliber weapon might force the Mosquitoes to break off their attacks. But the British pilots seemed to understand exactly where the boundaries of effective fire lay, maintaining their distance while methodically pumping shells into the convoy, their measured rate of fire suggesting they were conserving ammunition, rather than spraying rounds wildly. The second Tsetse's attack run focused on U-960 itself, Flight Officer Turner lining up his sight on the submarine's conning tower where the concentration of anti-aircraft weapons posed the greatest threat. His first shell striking the bridge structure and sending fragments scything through the gun crews, Steinberg feeling the impact through his feet as the 57mm projectile tore through the submarine's outer casing, rupturing fuel bunkers and sending diesel oil streaming into the boat's wake. The escort vessels attempted to generate a smoke screen to obscure the submarine, but the Mosquitoes' altitude advantage allowed them to see through gaps in the artificial fog, their pilots adjusting aim points based on the last observed positions of targets. The 57mm shells continuing to find their marks with disturbing regularity, each impact degrading the convoy's defensive capability as gun positions were knocked out and ammunition supplies detonated. Squadron leader Phillips made a second attack run, this time targeting one of the minesweepers that had moved to shield U-960, his remaining shells striking the vessel's bridge and engine room, causing it to lose speed and fall out of formation, smoke pouring from ventilation grates as fires spread through the ship's interior, the crew abandoning their gun positions to fight the flames, creating gaps in the defensive screen that the conventional Mosquito fighter bombers immediately exploited. The psychological impact on German crews was profound, with gunners realizing their weapons could not effectively engage the attacking aircraft, leading to a sense of helplessness that undermined morale more effectively than conventional bombing attacks where at least the defenders felt they were fighting back, this new reality forcing a fundamental reconsideration of convoy defense tactics that had seemed adequate just months before. In the aftermath of the attack, as U-960 limped into La Pallice with 3 escort vessels damaged and hundreds of casualties, Steinberg's after-action report emphasized the impossibility of defending against aircraft that could engage from beyond effective flak range. recommending that future convoys require fighter escort throughout their passage rather than relying solely on anti-aircraft guns, a suggestion that revealed how completely the Mosquito Tsetse had disrupted German defensive doctrine. The Technical Intelligence Section at Kriegsmarine Headquarters initially refused to believe that the British had successfully mounted a 57mm gun in an aircraft, with experts arguing that the recoil forces would exceed the structural limits of any wooden airframe, but recovered shell fragments and the testimony of multiple witnesses eventually forced acceptance of this new reality, leading to urgent requests for longer-ranged anti-aircraft weapons that could engage the Mosquitoes before they reached their firing positions. Wing Commander Tony Phillips would continue flying the Mosquito Tsetse through the spring of 1944, participating in the attack on Japanese submarine I-29 in May, where his 4 shells destroyed a Junkers Ju-88 fighter, one projectile tearing the aircraft's engine completely off in a demonstration of the 57mm gun's devastating power against aircraft as well as ships, though this was considered a bonus rather than the weapon's primary purpose. The Molins Company received recognition for their contribution to the war effort, with Desmond Molins awarded the U.S. Medal of Freedom for his innovative adaptation of cigarette machinery technology to military purposes. Though the company would return to civilian production after the war, their brief foray into weapons development remaining a closely guarded secret for years as the true capabilities of the Mosquito Tsetse were classified. The German response to the Tsetse threat included rush development of new anti-aircraft systems, including experiments with guided missiles and proximity-fused shells that could engage aircraft at extended ranges. But these programs came too late to affect the outcome of the Battle of the Atlantic, with U-boat losses continuing to mount through 1944 as Allied aircraft exploited their technological advantages to devastating effect. Italian naval officers studying German after-action reports noted with concern that their own anti-aircraft defenses were even less capable of dealing with standoff attacks, with most Italian vessels equipped with 20mm Breda guns that had even shorter effective ranges than German weapons, leading to desperate attempts to acquire German 37mm and 40mm guns that might provide some capability against the new threat, though Italy's surrender in September 1943 ended these efforts. The Japanese submarine force, preparing for their own missions to European waters, incorporated lessons learned from I-29's encounter with the Mosquito Tsetse, adding additional anti-aircraft weapons and training gunners to engage aircraft at maximum range regardless of ammunition consumption. Though these measures proved ineffective when I-52 was caught and sunk by conventional Allied aircraft in June 1944, the submarine's enhanced defenses unable to prevent its destruction. Production of the Mosquito Tsetse continued through 1944, with approximately 27 aircraft completed before the program was terminated in favor of rocket-equipped fighter bombers that offered greater versatility despite lower accuracy. The decision influenced by the declining U-boat threat and the need for aircraft that could attack multiple target types without extensive modification, though veterans of 248 Squadron maintained that no other weapon matched the Tsetse's ability to destroy hardened targets from safe distances. The psychological warfare aspect of the Tsetse's employment extended beyond its direct combat effectiveness, with German submarine crews becoming increasingly reluctant to surface even when traveling in heavily defended convoys, knowing that British aircraft possessed weapons that could penetrate their boats' pressure hulls from distances where return fire was ineffective, this fear contributing to the virtual abandonment of U-boat operations in the Bay of Biscay by late 1944. Technical analysis of the Molins gun system revealed ingenious solutions to problems that had stumped conventional weapons designers, with the automatic loading mechanism using principles derived from high-speed packaging equipment to achieve reliable feeding despite the violent maneuvering of aerial combat. The 5-tray magazine system allowing sustained fire without the frequent reloading interruptions that plagued other heavy aircraft weapons. The evolution of German anti-aircraft doctrine in response to the Tsetse threat included desperate measures such as mounting Army 88mm flak guns on specially reinforced vessels. Though these weapons proved too slow traversing to track fast-moving aircraft effectively, their primary value being psychological as gun crews felt they could at least attempt to engage attacking aircraft even if hit probability remained minimal at extended ranges. British pilots flying conventional Mosquitoes alongside the Tsetse variants developed coordinated tactics that maximized the effectiveness of both aircraft types, with the 57mm equipped planes suppressing anti-aircraft positions from long range while standard fighter bombers closed to deliver rockets and cannon fire against vessels whose defenses had been degraded, this combined arms approach proving devastatingly effective against even heavily defended convoys. The industrial infrastructure supporting Tsetse operations included specialized maintenance facilities at coastal command bases where the complex Molins gun mechanisms could be serviced, with technicians trained in both aircraft systems and artillery maintenance working together to keep the weapons operational, their expertise representing a unique fusion of technologies that had never before been combined in military service. German attempts to develop countermeasures included experiments with radar-directed flak systems that could theoretically engage aircraft at extended ranges. But the wooden construction of the Mosquito provided a poor radar return while the aircraft's high-speed complicated tracking solutions, factors that combined to make existing German radar fire control systems ineffective against this new threat. The impact on submarine operations extended beyond direct losses, with boats forced to travel submerged for extended periods to avoid air attack, dramatically increasing transit times and reducing operational efficiency, while the need for heavy surface escort consumed destroyers and minesweepers that were desperately needed for other missions, creating cascading effects throughout the Kriegsmarine's force structure. Post-war analysis by the United States Navy's Operational Research Group concluded that the Mosquito Tsetse represented an optimal solution to a specific tactical problem, providing standoff engagement capability against hardened maritime targets without the complexity and expense of guided weapons, though American forces chose to pursue rocket and torpedo solutions that offered greater flexibility despite lower accuracy. The human cost of the Tsetse's success included hundreds of German sailors killed or wounded by 57mm shells that penetrated their vessel's armor, with survivors describing the psychological trauma of being under fire from weapons they could not effectively counter, leading to morale problems that persisted even after boats reached the relative safety of fortified ports. Squadron records from 248 Squadron indicate that Tsetse pilots required extensive training to master the unique flying characteristics of their modified aircraft, with the off-center gun installation creating asymmetric thrust that complicated engine-out procedures, while the weapon's recoil affected trim in ways that required constant adjustment during firing sequences, skills that took weeks to develop even for experienced Mosquito pilots. The strategic implications of the Tsetse's success influenced Allied planning for Pacific operations, with proposals to deploy similarly armed aircraft against Japanese shipping, though the surrender of Japan ended these plans before modified aircraft could be sent to the Far East, leaving the Mosquito Tsetse as a unique European theater weapon whose full potential was never completely realized. Maintenance challenges included barrel wear from the high-velocity 57mm rounds, with guns requiring replacement after approximately 200 rounds, a limitation that restricted sustained operations and required careful ammunition management during missions, pilots learning to conserve their 25-round basic load for high-value targets rather than expending shells on targets of opportunity. The intelligence value of captured German documents discussing the Tsetse threat provided insights into enemy morale and defensive planning, with translated reports revealing the depth of concern among U-boat commanders about their inability to counter this new weapon, fears that Allied propaganda exploited by publicizing successful Tsetse operations to further undermine German confidence. Environmental factors affecting Tsetse operations included the notorious Bay of Biscay weather, with fog and storms limiting flying days while rough seas complicated aiming calculations, pilots learning to adjust for ship motion when engaging moving targets, skills that required extensive practice in combat conditions where mistakes could prove fatal. The legacy of the Mosquito Tsetse influenced post-war aircraft armament development, with several nations experimenting with large-caliber aircraft guns for anti-shipping roles, though guided missiles ultimately proved more practical for standoff engagement, rendering the concept of flying artillery obsolete except for specialized ground attack missions. German naval architects studying the effectiveness of 57mm shells against submarine hulls concluded that existing boats were vulnerable to this weapon at ranges exceeding 2,000 meters when struck at optimal angles, leading to proposals for increased armor protection that were never implemented due to weight constraints and the war's end. The coordination between coastal command and intelligence services that enabled successful Tsetse operations represented a model of inter-service cooperation, with ultra-intercepts providing targeting information while reconnaissance aircraft confirmed convoy positions, allowing strike aircraft to achieve maximum effectiveness with minimal risk. Training protocols for Tsetse crews emphasized deflection shooting and range estimation, with pilots spending hours practicing against towed targets to develop the instinctive lead calculations required for accurate long-range gunnery, skills more commonly associated with naval surface combat than aerial warfare. The final Tsetse mission occurred on April 5, 1945, when Mosquitoes attacked German surface vessels in the Kattegat, sinking 5 ships including a Sperrbrecher with all hands, demonstrating that even in the war's final weeks, German forces remained unable to counter this weapon system effectively, the 57mm shells finding their marks despite desperate defensive fire. Analysis of ammunition expenditure records shows that Tsetse aircraft achieved approximately 1 hit for every 3 rounds fired at naval targets, an exceptional accuracy rate that validated the original concept despite the weapon's limited production run, proving that conventional guns could provide precision strike capability when properly employed. The human engineering aspects of the Tsetse included special pilot restraints to prevent injury during weapon firing, with shoulder harnesses reinforced to withstand the sudden deceleration caused by recoil, while navigators required additional padding to protect against impact with equipment during the violent pitching motion that accompanied each shot. German propaganda attempted to minimize the Tsetse threat by claiming the weapon was ineffective against properly defended convoys, but internal Kriegsmarine communications revealed deep concern about this new capability, with admirals privately acknowledging that no effective counter existed within existing German technology and doctrine. The industrial mobilization required to produce Tsetse aircraft included coordination between de Havilland's aircraft factories and the Molins machinery works, with components manufactured at separate locations then brought together for final assembly at specially configured facilities where the precise alignment of gun and airframe could be achieved. Tactical evolution in response to the Tsetse threat included German experiments with decoy vessels equipped with numerous anti-aircraft weapons but minimal armor, intended to draw fire away from valuable submarines, though British intelligence quickly identified these ships and instructed pilots to ignore them in favor of confirmed submarine targets. The meteorological constraints on Tsetse operations included minimum visibility requirements for long-range gunnery, with pilots needing clear sight lines to targets at distances where conventional bombing would be conducted by radar, limiting operations to daylight hours with reasonable weather conditions. Post-war interviews with German naval personnel revealed that the psychological impact of the Tsetse extended throughout the U-boat force, with crews who had never encountered these aircraft still fearing them based on accounts from survivors, creating a mythology around the weapon that exceeded its actual employment numbers. The cost-effectiveness analysis conducted by the Air Ministry showed that despite the expense of modifying aircraft and training specialized crews, the Tsetse program provided exceptional value by destroying or damaging high-value targets with minimal losses, validating the concept even as it was being phased out in favor of rockets. Technical documentation from the Molins Company archives reveals the extensive testing required to perfect the automatic loading mechanism, with thousands of rounds fired in ground tests before the system was certified for flight operations, each component tested to destruction to ensure reliability under combat conditions. The influence of the Tsetse program extended to other British aircraft development projects, with designers considering heavy gun armament for various aircraft types, though only the Mosquito possessed the combination of speed, range, and structural strength required to successfully employ such weapons in combat. German efforts to obtain intelligence about the Tsetse included attempted recruitment of personnel from the Molins factory, with Abwehr agents offering substantial sums for technical information about the gun mechanism, though British security services successfully prevented any significant breaches despite several close calls. The operational doctrine developed for Tsetse employment emphasized patience and precision over aggressive attack, with pilots instructed to maintain optimal firing range even if it meant prolonged exposure to enemy fire, trusting in their aircraft's speed and distance to provide protection rather than violent maneuvering. Statistical analysis of mission reports indicates that Tsetse aircraft achieved their highest success rates when operating in pairs, with one aircraft suppressing anti-aircraft positions while the other engaged primary targets, this tactical innovation maximizing the limited ammunition capacity while minimizing exposure to return fire. The termination of the Tsetse program in early 1945 reflected changing operational requirements as the U-boat threat diminished and Allied forces required aircraft capable of supporting ground operations, with the specialized anti-shipping capability no longer justifying dedicated aircraft when rockets could provide adequate effectiveness against remaining maritime targets. Historical evaluation of the Mosquito Tsetse's contribution to Allied victory emphasizes its role in maintaining pressure on German submarine operations during the critical period of 1944, when new U-boat types were entering service, preventing the Kriegsmarine from regaining the initiative despite technological advances in submarine design. The preservation of Tsetse aircraft for museums proved challenging due to the classified nature of the program, with most aircraft scrapped or converted back to standard configuration after the war, leaving only photographs and technical drawings to document this unique weapon system that briefly revolutionized maritime strike operations. Veterans of 248th Squadron maintained informal reunions where Tsetse operations were discussed, their accounts providing valuable historical documentation of a weapon system that remained largely unknown to the public for decades. the full story only emerging as wartime classifications expired and official histories were compiled. The broader implications of the Tsetse program included demonstration that conventional weapons could be adapted to meet emerging tactical challenges without requiring entirely new aircraft designs, a lesson that influenced military procurement strategies emphasizing modification of existing platforms rather than development of specialized single-purpose aircraft. Contemporary military analysts studying the Tsetse program note its relevance to modern anti-ship warfare, where standoff engagement remains critical for aircraft survivability, though modern solutions employ guided missiles rather than the direct fire guns that briefly gave the Mosquito unprecedented ship-killing capability during the Second World War's final phases. The convergence of technologies represented by the Mosquito Tsetse, combining aircraft design, artillery systems, and industrial automation, exemplified the innovation that characterized Allied weapons development during the war, with unlikely combinations of existing technologies creating capabilities that enemy forces could neither anticipate nor effectively counter. In conclusion, the Mosquito Tsetse represented a brief but significant chapter in the evolution of aerial warfare, demonstrating that innovative thinking could overcome seemingly insurmountable tactical challenges. Its success measured not just in ships destroyed but in the fundamental disruption of enemy defensive doctrine that forced the Kriegsmarine to reconsider every aspect of submarine operations, from convoy formations to anti-aircraft armament, none of which ultimately provided effective defense against aircraft that could engage from beyond the range where German weapons could respond, leaving submarine crews and their escorts vulnerable to precision strikes they could neither prevent nor properly counter. A reality that contributed significantly to the final collapse of the U-boat threat and the Allied victory in the Battle of the Atlantic.